Assalamu alaikum. So the lesson today is about system of equations. Today we are going to learn how to solve 2 by 2 system of equations using inverse matrix. So in order for us to use inverse matrix, we need to have two concepts. The first concept is the determinant, and the second concept is to learn how to find the transpose of a cofactor matrix. So if you have no idea about how to find out the cofactor matrix and its transpose, so please see my previous lesson about matrices, and you will learn how to find out the transpose matrix and how to find out the cofactor matrix of a matrix. So let's start. So we are going today to do 2 by 2 inverse matrix. So given a 2 by 2 system of equations, so we have ax plus by equals c, a1x plus b1y equal c1. So again, like the lesson 8, so in order for me to use inverse matrix, I need to transform the given system into matrix notation. So first, transform the 2 by 2 system from standard notation to matrix notation. So this is my first equation, this is my second equations. So I choose to have x is my first coordinate for the variable matrix. So I'm going to put the coefficient of x first. So bb1. So this is my variable matrix, and this is my result matrix. So we start with the first equation, so it's going to be c1. So after you set up your transformation from standard to matrix notation, so second we need to find out those two following: the determinant of the coefficient matrix and the transpose of the cofactor matrix of the coefficient matrix. So first you need to find the determinant. So second, find the determinant of the coefficient matrix and the transpose of the cofactor matrix of the coefficient matrix of a1, b1, which is in fact is b1 a. So you switch the diagonal and you take the opposite of the opposite diagonal. So it's that simple enough. So this is the transpose of the cofactor matrix of that matrix. So after you find out those two elements, so what you do, you proceed to the TCM test. So the third steps, what you do, so you do the TCM-test. So if the determinant, so if the determinant of the coefficient matrix A1, B1 equals 0, and the product of the transpose of the coefficient matrix of the cofactor matrix of the coefficient matrix, so B1 minus A1 minus BA times C1 is different than the matrix 0, so it's different than this matrix. So then the system is inconsistent and you have no solution. Then the 2 by 2 system is inconsistent, so which means you have no solution. So this is the first case. The second case, if the determinant of the coefficient matrix is equal to 0 and the product of the transpose of the cofactor matrix of the coefficient matrix, so B1 minus B minus A1A, so here is minus A1A times C1 is equal to the matrix, the 0 matrix. So here the system is consistent dependent and we have infinite of solution. Then the 2 by 2 system is consistent dependent. So the conclusion will be infinite solution. And the third case, so if the determinant of the coefficient matrix is not equal to 0, then the system is, so I don't have to check that case. So then the system is consistent and dependent, and the 2 by 2 system is consistent and dependent. The solution will be xy equal 1 over the determinant time the transpose of the coefficient of the cofactor matrix of the coefficient matrix, so B1 so B1 minus B minus A1A times C1. So when you multiply those two and you divide each entry by the determinant, you will get the first entry is the x and the second one is the y. So at the end you will end up having B1 C minus B C1 over D, this is for x, and the minus A1C plus A C1 over D, and this will be your y. So this is the concept behind how to solve 2 by 2 system of equation using inverse matrix. So now let's do some practice. So suppose I want to solve that system. 4x minus y equal minus 7, and minus 4x plus y equal 28. So I will transform my system from standard notation to matrix notation. So this is my first step. My second step, I'm going to find the determinant of the coefficient matrix. So the determinant will be 4 minus 1, 1. So which is 4 minus 4. So we'll end up having 4 minus 4 equal 0. Then what I do, I'm going to multiply the transpose of the cofactor matrix, which is, like I say, you switch those two and you take the opposite of the opposite diagonal. So you switch the diagonal and you take the opposite of the opposite diagonal. So here I will have 1, 4. So you see I switch the diagonal, and those are negative, I will make them positive. You just take the opposite. If they are positive, they become negative. If both are negative, they become positive. Is one positive and the other negative, you switch. So the other one become negative and the other one become positive. All right, then I will time this. You see, I will time, this is the matrix, it's not the determinant. I will time this with minus 728 and see if it's going to give me 0 or different than 0. So for the first entry, so I got the first entry is minus 7 plus 28, and the second entry is minus 28 plus 1, 12. So obviously this is different than 0 because this is equal to 21, and here it's become 84, I think. And this is different than the 0 matrix, so which means the system is inconsistent, so no solution. So then the 2 by 2 system is inconsistent, so therefore no solution. Let's pick another example. For example, I want to solve for that one. So they ask me to solve for that system. We have 4x plus 5y equal 11, minus 2x minus 3y equal minus 5. So again, first I need to transform my system from standard notation to matrix notation. So I got 4 minus 2, 5 minus 3 x y equal 11 minus 5. Now, so what is my determinant? So the second I need to find out the determinant, which is 4 minus 2, 5 minus 3, which is equal to minus 12 plus 10, which is minus 2. This is different than 0. So what is my transpose of the cofactor matrix of the coefficient matrix is this matrix. So it's minus 3, 4. You see, I switch to diagonal and I take the opposite of the opposite diagonal. So this is positive, this is negative. This will become negative and this will become positive. So now what I do with this, because this one is different than 0, I will time. So I will time by the value of c. So this will be my x and y. Oh, by the way, I need to divide the whole thing by the determinant. So let me get some space. So I will get some space. So for example, I will do it here. All right. So here will be 1 over minus 2. So this is my determinant. So this will be my x, y. So it's going to be 1 over the determinant times the transpose of the cofactor matrix of the coefficient matrix times the result, which is 11 minus 5. So when I multiply, I got minus 1 over 2. So A is going to be a minus 33 plus 25. And here will be 22 minus 20. So it's going to be minus half minus 8. And here will be 2. So so what's going to be my value of, did I miss anything here? Or I miss write my, okay, so here will be my xy, because sometimes just little sign can mess up everything. This is why you have to be careful. So just this is what I want to just check. So here I divide each term of the matrix by that coefficient, so it will be 4 minus 1. So this is the result of this matrix because it is consistent and dependent. The determinant is not 0. Now let's do another example. So let's see what I will get with that one. So I'll get minus 3x plus 4y equal 19, minus 3x plus 4y equal 19, and I have 3x minus 4y equal minus 19. So let's transform the system from standard to matrix notation. Minus 3, 3, 4, minus 4 times x, y equal 19 minus 19. So first let me find my determinant. Minus 3, 3, 4, minus 4. 12 minus 12 equal 0. Then what I do next, when it's equal 0, I will do my TCM test. So I multiply the transpose of the cofactor matrix of the coefficient matrix. So here what I do is switch those two. So it's going to be minus 4 minus 3. And I take the opposite of the opposite diagonal. And I time it with the result matrix. And see what I will get. If it's equal 0, we have infinite of solution. If it's different than the 0 matrix, that means there is no solution and the system is inconsistent. So here I will have minus 4 times 19 and plus, and we have minus minus, so it's going to be 4 times 19, and those are the same, that's the opposite, this means 0. Then we have minus 3 times 19 plus 3 times 19, so I don't have to multiply, it's straightforward here. So it's 0, 0. So, which means that the system is consistent dependent, so the two system, so then 2 by 2 system is consistent dependent, so we have infinite of solution. So infinite solution. So this is the idea behind how to solve a 2 by 2 system using inverse matrix. So and you're gonna tell me, okay, here there is no inverse matrix involved here. Yes, there is, because what I use, I didn't say it to you at the beginning, but when for the third case here, you see this is the first, this is the second, hold on here. All right, so when the system has a solution here, you see that that notation, which is the transpose of the cofactor matrix times 1 over d, is the inverse matrix of the coefficient matrix. of this matrix. So please see my video about matrix, inverse matrix, and transpose and cofactor matrix, so to learn how to find out the inverse matrix using those concepts. So thank you for watching the video, and I hope that you understand the big concept behind how to solve a 2 by 2 system using inverse matrix. And please, if you have any comment that will help me improve my way of teaching, it's really welcome. Thank you very much for watching the video, and Assalamu alaikum.